Okay, let's start with number one in section 4.3. And it says apply the translation theorem to find the Laplace transforms of the functions in 1 through 4. So this is number one. Now this section we're still working obviously with Laplace transforms, Laplace inverse transforms. We've worked with partial fractions as well. And now we're just going to combine it with translations, right? Because there are functions that translate. So it's very similar actually. If you're comfortable with, again, 4.1 and 4.2, we're just shifting. We have a translation basically on the s-axis. Okay, so let's go ahead and start this problem. And again, let me just right, these are the two formulas you're thinking of using, right? General formulas, depending if you want to find the Laplace transform or if you want to find the inverse Laplace. And remember, again, the new guy here is this a, right? Before it was just f of s, but now it's f of s minus a, right? It's a translation, a units, right, to the right. And similarly, right, if we find the inverse, right, this guy is the same thing as this guy. Okay, so this is, again, a general, obviously, well, it's a theorem, it's a general theorem. And I want you, if you look on page, let's see, page 290 of your book, they have a nice little table of f of t and capital F of t. And notice it's combinations of the exponential functions, right, with t to the n, cosine kt, and sine kt. And they're very similar to the table that we used in when we first started learning about Laplace inverse, Laplace transforms and inverses, I think in 4.1. The only difference is there is a shift of a. So this, if we look at this guy, this is, let's see, we have, what's the very first one? This is e, that right, this is, or actually this is my t to the n, right? And then this guy is e to the at, right, where a is pi. So according to our theorem, which, I mean, they basically just kind of summarize it there for some functions, we have the Laplace, right, transform of our f of t, so in this case t to the fourth, e pi t, is equal to, and then again, this is what we have. It's going to be a capital F of s minus a, but if you look at the table, it's specifically n factorial. Okay, well, what's n? Well, n is this guy right here, right? Our n is 4, so this is 4 factorial divided by s minus a. And what's our a? Well, our a is pi, so s minus pi raised to the n plus 1. So that would be 4 plus 1, so that's to the 5th power. And 4 factorial, right, that's just, and let me maybe go ahead and I like to work vertically. That's just, right, 4 times 3 times 2 times 1 all over s minus pi quantity to the 5th power. We don't have to multiply that out. So then we get 12 times 2, which is just 24, over s minus pi raised to the 5th. So that's what our Laplace a transform of this function is. Again, new translation, right? It's actually shifting pi units on the s-axis. So I'm going to go ahead and assign 2, 3, and 4, which are very similar, and I encourage you to use this table. Definitely write it down for your exam. It will be very helpful.